We've just talked about physical isolation and the need for it. Now some virtual isolation and compartmentalization methods that you can think about and potentially use yourself if you need to. First is with encryption. You can use compartmentalization with encryption, and you will with the protocols that you're using. So here are some examples of how you might use compartmentalization, virtual compartmentalization with encryption. You can separate data by its level of importance, or you can separate your assets by their level of importance by having, say, for example, one encrypted volume for confidential data, one for secret data, and one for, say, top secret data. And you use different encryption keys for each of those volumes. You could use a storage device like a NAS with separate volumes, each encrypted with a separate key. I have a NAS storage device with separate encrypted volumes. The secure volumes are virtually never mounted and decrypted because I don't need to access them very often. The day-to-day volumes are used for less secure, less secret data. This is a good method of virtual isolation to reduce the attack surface of the secure data. If, for example, I had some sort of ransomware, those drives are not mounted in order to be attacked. The encryption key isn't in memory because the drives are not mounted, a form of virtual isolation with encryption. You can use hidden encrypted volumes to make your data harder to find. And you'll find when you're using transport security, the use of separate session keys for encrypted messages, like with elliptical curve Diffie-Hellman for perfect forward secrecy, is an example of compartmentalization, separate sessions using separate keys. We talk more about encryption in other areas of the course. We have a section on file and disk encryption, which covers more of this. Another tool for virtual isolation is the Portable app. For Windows, these can be downloaded from this site here, portableapps.com, and also pendriveapps.com. Portable Apps has about 300 portable apps, so it's quite impressive what you can download from there, and you can see Firefox, Thunderbird, Chrome, Skype. These can be used with Linux, Unix and BSD via Vine, and Mac OS X via Crossover, Wineskin, Winebottle and Play on Mac. If you're not familiar, portable apps are standalone applications. They are self-contained and don't require an installation. When you install an application, such as a browser, the application files are stored in various locations over the file system and changes are made to the registry. With portable apps, all changes are contained to a single folder or file, making the application portable. So you can literally copy it, paste it somewhere else, and it will still work. That's not the case with installed applications. You cannot just copy and paste them, and then they will work. Portable apps have several benefits for security, privacy, and anonymity, and not many people take advantage of them. So let's go through some. So let's imagine we're using Firefox as a web browser. Data related to the browser history is contained within the portable app. This makes evidence concealment and elimination easier. The application could be placed on a physically secure device, like an encrypted USB, such as this one. So then it can be moved, it can be hidden, it can be destroyed. The application can be placed on an encrypted volume or even a hidden encrypted volume. This means that unless it's unencrypted, the application and its data is inaccessible. The application could be placed on both a physically secure device like this one and within this device put on an encrypted hidden volume, making a pretty stealthy app with its data self-contained. And you can have multiple instances of the application. You can just copy it, paste it, and you've got a separate instance, and you can create separate versions of it, separate security domains, separate profiles, separate aliases. So if we're going back to the example of the browser, you could have multiple profiles of that browser with different security extensions installed. The applications can be used on other machines, enabling you to use a secure application like a browser on another machine. You just take along your USB stick and plug it in the other machine, and you've got your secure, hardened Firefox on another machine as needed, or whatever application it is that you're using. Admin rights are not needed to run the application, so you can run them on systems you don't own. They enable plausible deniability. So let me give you an example. If you have a standard install browser used for normal non-private browsing, and you also have a second hidden portable browser on an encrypted volume for private browsing, your normal browser will be clean and available for forensic examination and will contain a full browser history. The portable app browser will remain hidden away and unknown about, giving you plausible deniability based around the evidence on your browser. You can store portable applications in the cloud, so you could put them with a file syncing service and then run them remotely over the internet on any machine that you decided to go on, meaning that your application isn't even installed locally or even remains locally. This gives you physical isolation as well, potentially making your application out of the physical or geographic sphere of influence of your adversary. So as you can see, some solutions provide both virtual and physical isolation and compartmentalization. Another example of this is applications as a service. For example, webmail. With webmail, all data can be stored with a third party, potentially helping someone store their data out of the sphere of influence of their adversary, creating physical and virtual isolation. You can even browse the web via remote services, preventing exploits from propagating back to your machine. There's no real name yet for these, as they are relatively unadopted, but are a good solution for security. I call them personally cloud browsers. Here is one example here, Authenticate. Maxthon's cloud browser is another option. Spikes have something called AirGap, which is the same sort of solution. And there's also Spoons.net, which have their browser sandbox. If you go down here, you see you can run various different versions of browsers, giving you both virtual and geographically physical isolation and compartmentalization. These will protect you very well from hackers and malware, as they cannot propagate to your machine by creating that virtual and physical isolation, but are a privacy concern and an anonymity concern, as they obviously own the browsers, they own the infrastructure, so they know where you're going and what you're doing. So unfortunately, good for security, good against hackers and malware, not so great for privacy and anonymity. Another isolation method that you can use is remote access. You can use terminal services, remote desktop, Citrix, TeamViewer, SSH, VNC, remote desktop manager, Zen desktop, Citrix receiver, Zen server, and so on. With these, you control a remote machine. This remote machine performs the tasks for you, and you just get the visuals back of what that device is doing. This isolates you from potential threats in the same way the cloud browsers do, because you are only viewing the desktop. Malware can't propagate to you via a screen update. So that's an option for you. You can set up your own remote access software on your own server for isolation. You could do that remotely if you have your own virtual server. I personally have a Zen server local to my network, and one of those VMs acts as a browser, which gives me virtual isolation when I'm browsing the web.